Hello everyone and welcome to this, another episode of 2D Prototyping in Unity. My name is Kisanas. In the last episode, we took a look at creating animations for our character. Right here in our character, we've got ourselves several different animations. We've got ourselves a player idle and a player run. We also set up the transitions between those two states using a parameter called speed, a float parameter called speed. In today's episode, I'd like to take a look at the code required to actually be able to switch between player idle and player run and back again, as well as make our character move back and forth across the screen. It's not going to be difficult. I know some of you are a little bit frightened of code. You say, oh, no code. I don't want to do code at all. You know what? It's not going to be a lot of code. I promise there's only a handful of lines for you to be able to make this character move around, and doing so is going to make you feel really great. You're going to say, wow, I'm on my way to making a game. You really are. Okay, so let's get started right now. So to start with, all you have to do is make sure, let's go into scene view. Let's make sure our character is selected. What we're going to be doing is we're going to be adding additional components to this character. We're going to be adding a script to this character. And that script is going to be responsible for a lot of things that are actually going to be happening to the character. Running, jumping, falling, shooting, everything like that. Okay, so what we're going to do is we're going to go with our character selected. And with our scripts folder selected, we're going to say add component. Oops, I hovered over there for too long. Add component. And we're going to say new script. What we're going to do here, right away we're going to see a new script behavior. Make sure you type in there the name, player controller. You want to make sure you get this right the first time, because changing it can screw things up if you don't change it in a couple locations. I'm not going to tell you about that right now, because you might just do it. Player controller. What I want to make sure that you guys are in C#. We're going to be using C# for this entire series. I prefer C# to the other options. The other options, of course, being JavaScript and Boo, I think, still is available. I like C#. It's a very strong language. I think a lot of people are moving towards C# for Unity if they're still doing scripting languages rather than down dirty coding like C++. But using C# is awesome. So that's what we're going to be using for this entire series. All right. Once you've got the name typed in there, player controller, then say create and add. Boom. What's going to happen is we're going to get a brand new node added to our character. That node, well, the script apparently showed up in assets. I'm going to drag it and drop it in scripts. Boom. That new node is called is the player controller script, and the only thing you're going to see in there right now is a reference to the actual script itself. Double clicking on it is going to open up MonoDevelop. MonoDevelop is the that didn't come out right, did it? Why is this? I must have torn that off. That's weird. There we go. Just a graphical error. Anyway, guys, MonoDevelop is the scripting editor that comes with Unity. It is a good scripting editor. I like it. I have no problems with it. Some people say they don't really like it, and you know what? If you don't, that's fine. You guys can use anything you want to use to write your scripts. I'm going to be using MonoDevelop. It's free and it comes with Unity. Free is awesome. So, right up here, we can see right away that we've got ourselves two functions available to us right now. We've got our start and our update. And we're gonna change these around in a little bit. The first thing we're gonna do. These are movement variables. All right. So the first thing we're going to do is we're going to add a couple of variables in here so that we can actually manipulate things either publicly or get reference to things that are currently on our character. So what we're going to do is we're going to add a public. And public means that if something is declared as a public, if a variable is declared as public, then it's going to be available to us over here in the inspector. Okay, it'll be available in the inspector. We'll be able to change it as we move forward without having to go through and change the script over and over again. And I'll show you what that means in 1 second. We're going to declare a public float that we're going to call max speed. Now, max speed is just as the name implies, the maximum speed that the character can move at. So by changing this, a lower value obviously makes the player move slower than a higher value. So if I put in a value of 1 or a value of 5, obviously 5 will move faster. And we're going to use this and tweak it. We made it public so that we can tweak it later on and get the right motion from our character. Okay? So that is our first variable. We're going to declare a couple of private variables here. And you don't have to explicitly write private. You can just start naming them. Rigid body 2D, and I'm going to call this my RB. What this is it is a reference to the rigid body that's located on the character. If you remember correctly, when we first built this character asset, one of the first things we added was a rigid body. Our character is a physics object. It has a rigid body, and what we want to do is we want to have a reference to that rigid body in order to be able to manipulate it in some way. We're going to manipulate the rigid body directly, either by adding forces or by changing the velocity or something like that, in order to get our character to move about the screen. So this is going to be a reference to the rigid body. Okay. The next thing we're going to add is a reference to our animator, and we'll call it. Let's call it my anim, I guess is fine. We are going to have a reference to our animator, and that is going to allow us to change our, if we go to our animator, it's going to allow us to change the parameters that we have listed here. Currently only speed. So what we're going to be able to do is manipulate speed in order to change these things here. Therefore, we need a reference to the animator itself. Okay? That's what those things are for. Now, we're going to go down here into the start menu, into the start function, which has been provided for us. And what I want to do is I want to initialize both my RB and my anim. Okay, and we're going to use the same technique to do both. We're going to say my RB is equal to get component. I'm not even going to type it because I'm so lazy. Get component. And basically what the get component does is it looks at the asset that this script is located on. It's gonna look at through the asset that this script is located on, and it's going to try and find whatever it is I'm looking for. In this case, my RB is a rigid body 2D. So it's going to be looking for our rigid body 2D. It's going to return a reference from this get component and store it here in my variable my RB. Okay? I'm going to do exactly the same thing with my anim, and I'm going to say is equal to get component. Okay, and I had a whole bunch of options there. I had get component and parent, get component and children, etc. Get component means it's located on the asset that I'm currently stored on as well. So get component, and this is going to be an animator. All right, this is going to return a reference to our animator and store it in my anim, and therefore we can directly manipulate now my anim. All right, now the next thing I want to do is I want to take a look and see if our player has gone through and added input into our game. So did the player click a button? Did the player push the arrow keys? Did they push a mouse button, etc.? We want to take a look at that. Okay. Now, because we've got ourselves a rigid body on our asset, this is a rigid body means that this is now a physics object. It means it can be affected by the physics engine. Now, update and fixed update are two options in order to be able to determine whether or not a player has pushed a button, whether input has been added into the game. We want to do our stuff in fixed update, and the reason why fixed update. The reason why update is called on after every single frame. After every single frame, regardless of how long that frame took to actually work. Fixed update is called after a specific amount of time all the time. It's exact. It'll always be called at, let's say, 0.1 milliseconds. It'll always be called at a specific amount of time, after a specific amount of time. So the fixed update difference, the differential between those two fixed updates is always exactly the same. In order to get physics engines working properly, in order to make sure that the physics objects are actually working properly, you want to manipulate them within the fixed update rather than the update. Okay, because the physics engine operates after each fixed update. After each time fixed update is called, the physics engine will actually operate on the actual physics object. Okay, so fixed update, excuse me. What we want to do in fixed update is we want to determine whether or not our player has actually pushed a button of some kind. And what we're going to do is we're going to check what's called the axes. Okay, so let's just start the code off before I show you what an axis is. So basically what we want to do is we want to declare a new variable, float, move. And move is going to be equal to input, right there, dot, get axes. You have a choice here, get raw axes and get axes. Get axes, what that basically does is it will return a value between -1 and 1. So any like 0.25454, whatever. get axes raw will only return a value of -1, 0, or 1. Okay, we want to know everything in between. We're going to be using that. We're going to be using everything in between, so we're going to use get axes. Now, what is an axes? An axes is a predefined value. Let me close this off for a second. A predefined value here in project settings input. A predefined value inside of Unity. So Unity has a number of axes. We can see that there's 18 in total that are already defined for you. Horizontal, vertical, Fire 1, Fire 2, Fire 3. Each one of these things here, let's take a look at horizontal because that's what we'll be using. Each one of these things here has a name associated with it, so an easy to reference name. And it has buttons associated. So the negative button is left button, so the left arrow button. The positive button is the right arrow button. The alternative on the opposite side of the keyboard is the A and the D for the negative and the positive. Okay, so basically what this is saying is this horizontal value is associated with these buttons, with A, D, left, and right. For us, what I want to do is I want to use the A and the D buttons, or the left and the right arrow buttons, to move our character around the screen. So I'm going to get axes. The axis that was defined over here is horizontal. All right, so basically what I'm doing is I'm saying, is the player pushing a button? Is the A or D or the arrow keys being pressed? If so, put the value, some value between, if you're pushing the A key, for example, you're getting a value between -1 and 0. And if you are pushing the D key, you're getting a value between 0 and 1. So take that value and put it into move, into our float variable move. All right. I then want to take that float variable move and I want to use it to directly affect my rigid body. There's a whole bunch of different ways of doing this. What I'm going to do, what did I call it? My RB. What I want to do is, no, I don't want to do that. I want to directly affect the velocity vector. That's a 2D vector. Some of you right now are saying, whoa, don't do that. You never ever affect the velocity vector. It's actually probably true. In a lot of cases you don't want to, because it gives unnatural movement, especially with physics objects. It gives unnatural movement because basically the velocity vector is a vector that determines how a rigid body is moving. And if I change it without adding force, if I just change the velocity vector instead of adding forces to it, then I'm not actually using the physics engine to move this character around. Instead, I'm using the velocity vector directly. And that's what we're going to do. Because we're making an arcadey style game, I'm not going to move the character around through forces by add force, which is what you would use if you wanted to add force to your rigid body. I'm not going to use the add force function. I'm going to directly affect the velocity, and that's going to give me an instantaneous change. So if you press the A button, it's going to be moving to the left, and if you press the D button, it'll immediately be moving to the right. You don't have to counteract any forces you've applied. We are going to be using this, the physics though, the physics for jumping and for falling. So it's not like our rigid body is not being used correctly. So anyway, guys, some of you are saying, don't use that, but I'm going to use it. I don't care. All right, so velocity is equal to a new vector 2D, because this is my rigid body is a 2D rigid body, which means it's only being affected in two-dimensional, in 2D. So it's a new vector 2, and what I want it to be equal to is, I want it to be equal to my move value. So the value, whether or not someone's pushing the button. If they're not pushing a button, it's going to be 0. If they are pushing a button, it's going to be between -1 and 1. My move value times my max speed. So right there, what that means is I'm going to be getting a value between negative max speed and max speed, depending on which button's been pushed. Okay, and by adjusting max speed, we'll then be able to make those values go up and down. All right. The y value of our vector 2D is going to be whatever the current one is. So it's going to be my RB dot velocity dot y. So I'm not actually, in this circumstance, I'm not actually changing the y value. Okay, the only thing we're manipulating is the x value of this vector 2D. The y value of the vector 2D is not being affected in any way. All right, I'm going to save this. I'm going to save my player controller, and we're going to come here and we're going to take a look at it. Now, If I typed everything correctly, then when I press play, we're going to be able to move this character around. Sometimes I don't do everything correctly, so let's take a look. Did I get any? Okay, good. I didn't get any errors. And if I press A and D, nothing's happening. I forgot to do something. The last thing I forgot to do to make sure this character is going to move is, if you remember correctly, let's go down here and take a look at this right now. If you remember correctly, we added a public variable called max speed. It was set to 0, so we were multiplying everything by 0. Let's give it a value of 5. Okay. When I press play now, play, and I move my character around, boo, boo, he's moving back and forth. I don't know if I like that speed. We're going to check it out in a minute. He's not flipping directions, and he is not going into the run, but we're going to take care of that as soon as we are out of here. So now we want to make sure that our character is flipping directions. That's the first thing we're going to take a look at, all right? Flipping directions. It's going to take a little bit of manipulation because we have to know which direction this character is already facing. And it's not going to be too hard to figure out. What we basically want to know, we already know if the player is pressing a button. We already know if the player is pressing either A or D or the arrow keys. All right, so if, let's do this. We're going to use an if statement here. If our move value is, let me make sure I get this right. Let's say our move value is greater than 0. So if our move value is greater than 0, that means that the player is pressing the D button. So they're facing, they want to move to the right. And 2 ampersigns to make sure we've got an and in there. And our character is, well, we don't have this set up yet, so we'll have to do something first. We're going to put in here an additional private variable called, let's call it facing right, and it's going to be a bool. It's going to be a Boolean value, bool. So it's he's either going to be facing right is true or false. So let's say facing right, facing right. So let's say if he's pushing down the D, he wants to move to the right, but facing right is not true, and you can say not true simply by doing that. If that's the case, then we want to flip our character. And we're going to have to write the flip function, which we don't actually have yet. All right, that's the first thing we want to do. Now, there's another situation. Else, if our player is move, he's pushing down the A key, so move is therefore less than 0. If move is less than 0 and our character is facing right, then once again we want to flip it. All right, flip. We don't actually have a flip function yet. We're going to write it in 1 second. So basically what this is saying is if our player is pushing the D key and he's facing left, then flip him around. If our character is pressing the A key and he's facing right, then turn him the other way. All right? We want to make sure in our start, let's actually initialize our facing right, and we're going to set it up it to true. So our character, whenever we start, we want our character to be facing right. Okay? So our facing right is true. Now, with this in mind, we're going to have to actually add a new function. So I'm going to come down here, boop, boop, and I'm going to say void, and I'm going to create myself a new function here. That's called flip, because that's what we called it above. It does not take any variables. That's our flip. And what we want to do, it's going to be a very, very simple thing. Basically what we want to do is we want to flip the graphic around. We want the character to face the other way. For our character to face the other way, we are going to use the negative value. Let's take a look. Let's go over to character for a minute. Let's go into our scene with our character selected. Watch what happens when I scale. Where's my character? Sorry. Watch what happens when I scale. What do I have selected here? Watch what happens when I scale the X of my character. All right, you see that? When I made it -2, my character flipped in the other direction. Okay? That is basically what we want to happen. We're going to just flip the graphic. We're not actually going to flip anything else. We're not going to make 2 different sets of animations or anything else. We're just going to flip the graphic. All right. So in order to do that, the first thing we're going to do, if we're in the flip function, we want to make facing right equal to not facing right. So it's going to automatically do the opposite. So whatever facing right was, if facing right was true, it's going to make it false. If it was false, it's going to make it true. It's just going to reverse it. That's the first thing we're going to do in here. The next thing we're going to do is we're going to take the scale. We already took a look at it over here, the scale in our transform. And we are going to make, we're going to say we're going to have a new vector 3, because scale is x, y, and z in the transform node, a new vector 3, and we're going to call it, let's call it, it doesn't really matter, we're going to call it the scale. All right, and that's going to be equal to our transform dot scale. Okay, actually it's going to be transform dot local scale, sorry, local scale. Just like it said there. So I'm taking the values from here, 2, 2, and 1, and I am placing it in the scale. Okay, I'm getting it from the transform, I'm getting the local scale, and I'm putting it into scale. I am now going to take the scale, the x value, the scale.x, and I'm going to say that's equal to, I'm going to say times equal, this is just a shorthand of writing this, times equal, -1. So what this is basically saying is take the x value and multiply it by -1, which is going to give me either -2 or 2, depending on what state we're in there. All right? So let's make it equal to -1. Then I want to take this entire thing. I want to say transform dot local scale, and I want to set it back equal to the scale. All right. So basically, all I did in this function is I took my facing, I reversed it. So whatever it was, I turned it the other way. I took my scale from my transform, and I put it in the scale. I multiplied the x value only by -1, because you saw that's exactly what we want to do here. We want to multiply this scale times -1, and then I put it back in the transform. Okay. Let me save this file. Save. And once again, as long as all my code is written properly, when I say play, when I move forward and I move the other way, you can see my character is now flipping back and forth. Great! We are almost there. We are almost there. Our character is moving back and forth, and he is flipping. The next thing we want to do now is we want to add the animation. And that is very easy to do as well. So, we've already got, let's go back here and take a look. So we've only got a handful of lines of code right now. What we want to do, we already have our reference to our animator right here. What we want to do is we actually want to set the value of our, let's go back and take a look at it in here, of our parameter speed to whatever the movement is. All right? And we want to do that right here in our fixed update. In fact, we want to do it immediately after getting our float value, our move value. So what we can do is we can say my anim dot, and now we want to reference that parameter. We have a choice of set, float, bool, etc. Ours is a float. Boom. Ours is a float. Speed is a float. And we want to give it, quotations, the name of the parameter, quotations, which was speed. We already said it was speed over there. We want to give it the value. We want to give it that parameter, and we want to give it a value. The value of that is going to be move value. Now, the problem is our move value is either negative. It's between -1 and 1, and we really don't care. Our speed value right now, if we go back and take a look at our animator, is set up so that whenever speed is greater than 0.1, it's going to move down here, and whenever speed is less than 0.1, it's going to move here. If they're pressing the A key and we pass in our movement value, well, it's always going to be less than 1, and it's never going to kick in. So we don't want that to happen. What we want to pass in is the absolute value of move. So just the value between 0 and 1, regardless of which input button they're pushing. Okay? So we want to use math.f dot ABS right at the top. That means absolute value, the absolute value of move. All right. So what that's going to return, instead of it returning a value between -1 and 1, it's only going to give us a value regardless of which key they're pressing, a value between 0 and 1. Okay. That's all we have to do. Let's save that. File, save. Now, theoretically, as long as we've done everything right, when we say play, our character will start running. All right, I have an exit time. There's something I forgot to do. So you can see that my thing kicks in. It takes a moment to kick in and kick out. It takes a moment for him to stop running. We're just going to go back here for a minute. We're going to take a look at this transition and make sure has exit time is not checked. And has exit time is not checked. All right, let's save that. File, save our scene. This thing is already saved. We don't have to do anything on here. I'll just do it to make sure. Good. And I'm going to play once again. We might have to adjust this value here. Maybe 0.01 is not enough. Let's try playing again. Running. Perfect. Look at that. He stops right away. That's exactly what we're looking for. Perfect. Okay. So now our character runs back and forth, flips back and forth, and goes from the idle state to the run state. Guys, we are moving along really, really nicely. What I want you to do, if you followed along with me now, the code is there, everything is there for you to be able to do what you want, to run back and forth. What I want you to do is go through and play with this value located right down here, your max speed, to get the feel you want for your game. You might want it faster, you might want it slower. You're going to have to adjust your max speed here. If you do, make sure you adjust your run speed so it's running appropriately as well. You want to make sure the feet look like they line up. And if you don't like the transition, make sure these transitions are smaller. If I want it to transition faster, I can squash it down even more. Did I just close that settings? Did I just close my thing? Where'd it go? Where'd it go? Anyway, make sure you squash it down. Try your play. And make sure it's looking the way you want it. Alright guys, we are moving along really well. I am happy with the way everything is going. I hope you guys enjoyed that. If you did, let me know with a thumbs up. If you didn't, a thumbs down is perfectly fine. If you're having a hard time with the code, don't worry about it guys. Practice makes perfect. Alright? If you have anything you want to tell me, comments down below. Thumbs up, thumbs down, comments down below, and if you haven't done so, please take a few seconds to subscribe. Have yourselves a wonderful day, everyone.